Hi everybody. Without revising the earlier concepts, because we have very less time, so I'd like to finish the regression and hypothesis testing both. Let's see if we can. Very quickly, talking about regression. Regression, see, what happens is regression is somehow similar to correlation. Okay, so similar to how in correlation we were trying to find the relationship between two sets of data, here also we try to find the same thing, but the approach is slightly different. In correlation, what we used to do is we saw each item by item, if something is increasing, if the other one is also increasing, and so on and so forth. Here what we will do is we will try to find a kind of line which goes through both the series in such a way that the what do you call it, the slope, sorry, the equation for that particular line will be such where if you put the value of one set of data in that equation, the other value can be calculated. What do I mean by that? No, whenever we have a straight line in a particular graph, right, so there would be an equation for it. So like we say y is equal to mx plus c, right? So m is nothing but your slope and c is nothing but your constant thingy. So what does that mean? If you know the value of x, you can calculate the value of y. So imagine there are x1, x2, x3, x4, and there is y1, y2, y3, y4. So what I'm saying is x1, x2, x3, x4, and so on and so forth. And similarly, we have y1, y2, y3, and y4. Now, if we have two sets of data like this, right? If we have x1, x2, x3, x4 as one data set of data, and y1, y2, y3, y4 is one set of data. Now I'm telling you other way around. I started from, if we have an equation, we can calculate each value of y if we have a value of x. Now I am saying other way around, think about it. If you already have x1, x2, x3, x4, you have y1, y2, y3, y4, how do you calculate the value of y is equal to mx plus c? That is what regression, that is where regression comes into picture. It finds the exact relationship between two sets of data, again used in various scenarios. We're not going to go there. We're just learning how to solve the question. Will it be perfect? No. There can be a scenario where there will be some error, but the regressor line is such that the error is the minimum possible error. That's what we are trying to do. Already formulas are given. The reason I told you this concept is so that we can explain our answer when we are done with the question. Very quickly, let's look at two formulas. One is for m, one is for b. Okay, so when I'm not going to read out the formula, I'm going to again go from the table, then I'll go to the formula. But if we know the value of m and b, the formula that we have is y is equal to mx plus b here. So instead of b, c, they call it b. It happens often, many times. So m is for slope. M value, we are calculating the value of the slope, and b is nothing but your constant value. So if we have the m value and b value, we will know y is equal to mx plus c equation. Once we know that, for each value of x, we can calculate each value of y. That is what our objective is here in a regression analysis. Now in regression, this equation is called regression line. On the basis of this line, we do a lot of other tests also again, but I see that in sir's notes he has not practiced questions based on those analysis parts, so I'm not going to cover that. We're just going to practice a question on calculation of m and b. Let's look at a question very quickly. We have x values and y values here given, right? And the question says find the equation of the regression line. So what we will do is we'll take the numbers as is, x and y. Similar to how we have been doing, we will not calculate here the mean will difference. Instead, what we will do in regression, this is the difference. Now there is no difference calculation. You can remember it like that. Regression, there is no difference calculation. You're simply multiplying, calculating the square of x and square of y, number 1 and 2. Okay, square of x and square of y. Then you are multiplying x and y for each of those items. Now, once you have done that, calculate the summation of all the values, all the columns. Calculate the summation of all the columns. Now look at it. How do we calculate the value of m? You take the summation of the last one, yes, let's divide the equation into two parts. One is numerator and there is denominator. In numerator, what you do is you take the summation of the last column, that is 1189. You multiply n with it. How many items are there? 5, right? 5 items are there for each of those groups. You multiply n with it and you deduct the multiplication of the summation of the first one and the second one. What did I say? You take the last column total, multiply n with it, you deduct the multiplication of the summation of first and second. That is your numerator. What is your denominator? You take the summation of the x square. You take the summation of x square, that is 375, multiply 5n with it. Again, multiplication of n is in both the sides, numerator also, denominator also. X square summation total multiplied by n, you deduct summation of x squared. You deduct summation of x squared. Once we do that, that comes as 856. So sorry, 802 and 506, both the numbers. Now that we have numerator and denominator, if you simply divide this by this, it will come to 1.58, which is already calculated on the left side if you look at it. Now, what did I say? I'll just repeat what I just said. We are now calculating the regression. We are preparing or finding out the regression line equation. In order to do that, we need the value of m and we need the value of b. How do we calculate the value of m? That is the complicated formula where we are now segregating numerator and denominator. For the numerator, what we did was last column total, multiply n with it, then deduct the multiplication of first column total and second column total. Aston, your video is on. Is it intentional? Yeah. Okay. So all right. So the denominator, what you do is you take the summation of the x square column, multiply n with it, and deduct the square of the summation of x column. Now both the values you get as 802 and 506, and you simply divide and it will be 1.58498. Let's look at the formula here. N sigma xy is nothing but your summation of the xy multiplied by n. N is your 5. Then minus sigma x is nothing but your summation of x, which is 37, multiplied by sigma y, which is nothing but your 139. That is summation of y, divided by n into sigma of x square. What does that mean? X square is this column. Summation of that 375 multiplied by n is 5, minus sigma x whole square. Sigma x is what? X column total, that is 37 to the power 2, that is square. That comes as 506. Any questions please on this equation? Please do practice.
Any shortcut, Dheeraj, like how you had explained for ANOVA and regression, correlation?
Shortcut as in, my bad?
For correlation and ANOVA, we don't need to remember the formula after, like you had explained us.
Yeah.
We need to create the data set. Calculate all the like x to the bar of mu.
Correct.
So here also, do we have such kind of methodology to?
You can form one actually from the top of you can actually. I haven't spent much time on it. If I spend, I may find another one. Just from the top of my head, let me do this. Okay, just remember the table. You are now computing the values and computing squares and then multiplying the values together. Let's name this table as 1, 2, 3, 4, 5. These are 5 tables. Okay, 5 columns. Sorry. Now, what your formula says is n into 5 minus 1 into 2 divided by n into 3 minus 1 square. What did I mean by that? Wherever I have written number, those are the columns. Okay, total of the columns. So n into 5 is 5th column total. 1 into 5 is first column total, second column total. N into 3 is what is x square total. Yes, 375. Now 1 to the power 2. So this squared I need to change so you don't get confused within that too. So I would rather say
You have to close into bracket that one.
Sorry?
Because we have square one. You need to close it within the bracket. Like
yeah, no problem. So that is one square. When I say one squared, one is nothing but your 37. So I mean, just from the top of my head, you can remember it like this, or you can remember it any other way if you want. I mean, that is what
I think this is easy. We'll remember in this way: 51231 square.
Yeah, 51231 square. Yes, you can say that, and don't forget n also in that. So yes, any other questions, please? Okay. Now, very quickly moving to B formula is simpler in comparison to the other one. Here, the value of M is going to be used, which we have already calculated. We simply take the second column total, 139, divided by the number of items, that is 5. Yes. And we deduct from it the total of the X column divided by N again, 5, multiplied with M. So this is the formula. If you look at it, total of second column, that is sigma y, divided by n. So you are basically calculating the mean of y. This is nothing but your mean of y. This is nothing but your mean of x. In the mean of x, you are multiplying m. M is nothing but what you have calculated earlier. So I can say it in a simpler form as mean of x series minus mean of y series multiplied by the second one is multiplied by m that we have calculated just above. So I've just simply done that only, and it comes to 16.07. Any questions, please? Sorry, I did it wrong. Okay, mean of y. The first one is mean of y. Second one is x. Okay. Okay. Now, if that is clear, then this is done. Then the regression equation you can form. Please take some examples. Any example you take, sirs. PPTs also have good examples there. You can take that up and solve questions through it, and try to remember the formula. Please.
As a joint date, what is the objective we are getting from this calculation? Because y is, we are not getting any value here, right? It's something like y is equal to some value multiplied by x plus 160. What we are getting from this objective means y is equal to what we are trying to conclude from this answer.
Yeah. So regression, as I said in the beginning, regression is something that is similar to correlation. Correlation, what it does is it tries to find the relationship of each item to item. What does that mean? If one item is increasing, what is happening to the other item? Is it decreasing or increasing? So and it finds a particular number which represents that relationship. If the correlation is 1, it is perfectly correlated. That means if it is the one number is 1, series X is increasing by 0.1, this one will also increase in the same proportion, basically. Now, regression is also a comparison between two series, but it is in a different perspective. How the perspective is different is this. For each number, we try to find out the exact relationship such that we can calculate the corresponding number of the other series. Now, once you have the equation here, you put the x value, any x value, it will give you the y value. So that means, as I was saying in the beginning, if we have x1, x2, x3, x4, y1, y2, y3, y4, we're trying to find out the equation through which, if we put x1 there, we can calculate y1. If we put x2 there, we can calculate y2. So that is the relevance of the equation. Equation helps us understand the relationship between two series in such a way that if we put the value of one number from one series, we can calculate the corresponding number of the other series. Does it make sense?
So it basically, if you have several points, it defines a straight line where it gives the mean of that and with appropriate standard deviation. So basically, it is bringing all those points into a line with a minimum error. I think that's what you told, right?
Absolutely correct. Absolutely correct. So not always, as like I was saying, no, it will not be as perfect as we normally do the equations. There will be error because all the points will not be falling under the same line. So there will be error, but the concept of regression is to minimize that error in such a way that we can that equation can represent our data. So that is what our objective is, and these formulas are built in such a way that that actually happens automatically. So this concept
actually,
part,
please. This problem, because they have given two variables, we are doing it. Actually, in regression, you find out one dependent variable and how does it vary with other independent variable. Independent variables. There can be 5-6 variables when we do a research, right?
Yes.
Like when we did our research, there were 2 or 3 parameters.
Correct.
So the regression gives us an equation where all those things fit in a proper, like what Dheeraj said. It defines in a way that there's a perfect correlation from one value, you can find the other.
Yeah, very true. Any other questions, please? Okay, please do solve questions so that you can remember the formula. What happens is it's easier to remember now that we have discussed, but if you don't practice actually in the exam hall, you tend to forget, or you tend to mix different formulas, because there's so many formulas. Easily there are around 15 to 20 formulas that we have to remember for tomorrow, right? So be careful, practice at least few questions from this. And this is I think a very simple question like this only will be there, not too much complication will be there, that's for sure. Yeah, so quickly. Yes,
I have a question not related to this LPP. There is a solution which is shared by sir, right? But there is no graph. The question is, there are 3 data points like X, Y, and Z. So how we are going to plot it in a data points in a table format and get it? So is it like we have to do 3, like setting X1 and X2 is equal to 0, then calculate X3? Like how we?
Sami, can we finish off the hypothesis?
Yeah, sure.
And deal with this latter? Because I believe LPP we have covered in detail. Please watch those videos. We have comprehensively practiced a lot of questions, more than 6-7 questions. And if your concept is clear from that, that's all right. We don't have to go by specific question, because again, time constraint is there.
Okay. No worries.
I have actually stopped my work in order to conduct this, and I'll be starting my work after this is over. So we have very less time. I'm planning to finish this off at least by 7:30. So hypothesis testing is going to take some time. So let me find out some time after that. If I have, then we'll discuss that specific question that you're talking about. Otherwise, just have the general knowledge. It's okay. If one question, some difficulty is there, not a problem. You remember the process, you can solve the question in the exam hall. That's not a problem.
Okay.
Yeah. Okay. All right. Quickly moving to hypothesis testing. Let's go here. Here that now we are coming to hypothesis. The basics we have to understand, because it often actually confuses people. Let's understand first of all null hypothesis and alternate hypothesis. So there was this logic that
sorry, Dheeraj, before we jump in the hypothesis, there is a regression analysis. Is that also required, or do you think that
that's what I was saying also. On the regression analysis, actually sir has not practiced in equation. There are things, R value or something called as R square, like that. A lot of numbers are there, but those sir has just given the definition of it. I believe there would not be a question, numerical question on it. At best, there can be a theoretical question. So please read through that content. I don't think there will be a numerical question from that.
Sure. Thanks, Dheeraj.
Yeah, perfect. Quickly talking about the null hypothesis and alternate hypothesis. Now, often, what is this hypothesis? I mean, whenever we are taking a decision, okay, in each decision, it can be either or, right? Suppose we have to attend the exam. Either we will attend the exam or we will not attend the exam. So for each decision, there will be a either or. So those are actually called in another language as what do you call it? Null hypothesis and alternate hypothesis. Any decision you call that for that. I mean, do you eat, so you want to eat have an ice cream, okay? So will you have ice cream? Will you not have ice cream? So these are decisions, right? So many factors will be considered in order to decide, should you have ice cream or should you not have ice cream. So in order to decide, you have to know what is your decision. In order to make the decision very clear, they have named it so formally as hypothesis, and they call one of those as null hypothesis, other one as alternate hypothesis. Let's get to know which one is null hypothesis, which one is alternate hypothesis. Sir has given very nice logic to it in order to decide that. So null hypothesis will be something that we know. something that we are hypothesizing, or it is a universal truth, it is a knowledge, or it is about a population. Now, what do we know? We know that Earth moves around the sun, right? So one can say that Earth moves around the sun. The another one can say sun moves around the Earth. Which one is null hypothesis? Which one is alternate hypothesis? Can somebody tell?
Earth moves around the sun is a null hypothesis,
yes,
because
something
we know
that we know. Yes, something that we know. So you got the logic how to apply this, right? Yeah. So similarly, the universal truth also here comes in, knowledge comes in, and so on and so forth. And the other way around, alternate hypothesis. If we are hypothesizing something to be greater than something or less than something, or we are claiming that this should be something, we are estimating something. So those are falling under alternative hypothesis category. Now, suppose I would say, sorry,
alternate is something like research, like where you require research to prove your analysis or assumption.
I'll tell rather, instead of finding a common word, remember these exact points: more than, correct, less than, claims, estimated, statement. Whenever you have a question, whatever question asks you to prove, whatever the question asks you to prove, try to relate it to one of these words. Whichever seems similar, make that proving statement to be that hypothesis. We'll just practice a question on it. Don't worry about that. I'll tell you how to apply this basically. But remembering remembering it is your task. How to remember these two words. So no is hypothesis, universal truth, knowledge, population is null hypothesis. More than, less than, claims, estimated, statement that we would like to prove is alternative hypothesis. Any questions on this, please? Okay. Now, whenever we will have hypothesis testing, what we will do is we will either prove this side or we will prove the other side. Basically, either we will accept, we will reject the null hypothesis, or we will not reject we fail to reject the null hypothesis. So how do we do that? It depends on something called Z value. Okay, depending on Z value, we will take the call. Now, if your Z value is less than equal to the critical Z value, the calculated Z value is less than equal to the critical Z value. In that case, you reject the null hypothesis. If your Z value calculated is more than your critical Z value, in that case, you fail to reject the null hypothesis. Now, before we go to how to calculate Z value, let's talk about critical Z value. What is this? This is a standard that is given by statistics. Okay, so when you have a series like left tail or right tail, as the case may be, so on and so forth, and you have your confidence level, right? You have your confidence level.
It is significance. It's a significance level. Right? Alpha is a significance level.
So the significance level is nothing but 1 minus confidence level. Correct. Right? So 95% if is your confidence level, then you know your alpha is 0.05. So that's a good point. That gave me the opportunity to make that point. So guys, when we are talking about something called significance level or the alpha thingy, so these are actually reciprocal to each other. So when you have 95% confidence over your decision, want to have 95% of decision, then you are letting go of 0.05. So alpha is nothing but your 0.05. So based on that, you will be calculating the critical Z value. Now it is already provided as 1.64 for 0.05. I'm telling you 90% of the questions have 0.05 alpha only. So please do remember 1.64. You don't need to look at the table. It will always be 1.64. Okay. Now that we know the critical Z value, we need to calculate the value either more than or less than. Accordingly, we'll take the call whether we reject the null hypothesis or fail to reject the null hypothesis. Any questions, please, as of now?
Dheeraj, you mentioned always remember 1.64 value, right? So this comes into picture when your alternate hypothesis is not equal to means mu equals to not equal to some value. In those cases, we have to create a two-tail test. And in two-tilt test, we can't take Z critical value as 1.64. We have to take 1.96 or 1.96. Correct?
Correct.
For 0.05 alpha.
Samir, have you seen a question with two-tilt test in our
yeah,
SIRS note?
We do have. I think we do have. We will see that.
This question which you have given, that has been solved as a two-tailed earlier.
Correct. We can proceed further.
I'll
tell you. I'll tell you. Like,
this one, he has solved it as two-tailed. Because he says one thing he has given is, if it is greater than thing, then it will be right-handed. If it is less than, it will be left-handed. And if it is null hypothesis, basically, if it is not equal to, it will be two-tailed. Though the answer will be on one side only, because.
Okay, if you want the question, I can tell you the question. It is 1 second. Let me tell you the question.
Same question.
Yeah, theater owners. It's a two-tail. What do you say? Two-tail hypothesis testing.
Which one? Sorry.
Theater owners in India knows it's a session number. I'm not sure, but 26 page number.
All 11, session 11. I think all these hypotheses is on.
Yeah.
11 or 7. Yeah, 11.
Because I solved all the problems. So I remember it, like it's 1.96.
Yeah.
No worries, no worries. Please proceed. We can solve directly that problem.
No, you're actually right. I just saw that question. Yes, I was thinking that I had the idea that the two-tilt test was not practiced in the class, but
no,
you are right. It is actually there. Yeah, you're right. So let's solve this question, then we'll move to that. So as of now, please remember 1.64 only. We will discuss that one separately if we have time today. Two-tilt test one. Please don't get confused. It's okay. What is the two-tilt test? How do we determine the left tail, right tail, or two-tail? I haven't discussed yet. That reason being, I was thinking that two-tilt test is not there at all, so we'll solve it without even thinking about it. But now that has come, once we have that question in test, I'll discuss that part. Don't worry, please. Now, as I have told, only remember 1.64 will be your Z critical value, and based on that, we will take our decision. Okay. Please, any other question based on it, on this?
No.
Okay, awesome. Let's quickly move to a question. And I haven't discussed the formula, if you have noticed, because I'll be discussing the formula only with the question. Let's read the question. An agency claims that average monthly disposable income is of families in Bangalore is greater than rupees 4,200. The moment you see this greater than, agency claims that average monthly disposable income is of families in Bangalore is greater than 4,200. Is it a null hypothesis or an alternate hypothesis?
It's a null hypothesis. So greater than means an alternate
null hypothesis. It's a known fact.
Where sorry, which question? Okay. 42,000.
It's not an assumption or estimates or other thing. It's a given.
No, it's claiming, right? It says like an agency claims that an average monthly disposal income is claim. Whenever, like, as you see the words like claim or greater than, then we have to set it this as an alternate hypothesis. HA is greater than 4,200. Then our HO will be, null hypothesis will be less than or equal to 4,200.
He's actually right. Sami, you are absolutely right. This is actually an alternate hypothesis. So because the greater than is there and it is a claim, so it is alternate hypothesis. So what will be the null hypothesis for this? Exactly opposite of it. So if the claim is greater than 4,200, then the null hypothesis will be less than or equal to 4,200. Make sense, everybody? Yeah. With standard deviation of rupees 3,200, so standard deviation is given. We haven't discussed the formula yet, but in the formula, the standard deviation is going to be used. Now, from the sample of 40,000 average disposable income was estimated at rupees 4,500. What does this mean? So 40,000 sample of 40,000. So basically, we have taken sample of 40,000 people. Out of everybody in the city, we have taken sample of 40,000. So what is the sample size when I ask? How much will you tell? 40,000, right?
Yeah.
That's
so what happens is when you read the question, you have to actually relate which number is which in order to apply the formula, because these questions are very simple. It's just to understand which value is which. That's where the the confusion lies. Now let's move on. From the sample of 40,000, average disposable income was estimated at rupees INR 4,250. What is this 4,250? This is your mean of your sample. Whatever sample that you have taken, mean of that. Why do I say mean? Because it is saying average disposable income. The moment average comes into picture, you say it is a mean only. Everybody agrees? Mean is nothing but average. So when it says average disposable income was estimated at rupees 4,250, I mean to say that is mean, but for the sample only. For 40,000 sample, the mean is 4,250. As of now, what do we know? Okay, what do we know? We know 4,200. 4,200 is what? It is our population mean, right? By population mean, that's what we need to figure out. That all average of all the people is 4,200. So the whole population average, we are targeting it to be 4,200 or more than 4,200 as the case may be. Now that is our population mean. Now standard deviation is given as 3,200. Then we have sample size of 40,000. Then we have mean of sample as 4,250. Then assume population standard deviation is 3,200. It need not be given. It was already provided there. Again, they have provided again. Let's read out the next one. Conduct a suitable hypothesis testing at 95% confidence level. As I was saying, 90% of the cases, the confidence level will be 95%. So your alpha will be 0.05 only. So your Z critical value is how much? Can somebody repeat?
Sorry, Z critical.
1.64 only. 1.64 is your Z critical value. Now let's apply the formula. The formula is something like this. Now I won't, so this is X bar is nothing but your sample mean minus mean, that is your population mean. Sample mean is how much for us? Can somebody tell?
4,250.
4,250, absolutely perfect. Population mean is how much for us?
4,200.
4,200 is absolutely correct. Divided by standard deviation divided by root n. Standard deviation is how much given?
3,200.
3,200. Then sample size is?
Square root of 40,000, which is equal to 200.
So you apply the formula, you get the value of Z as 3.125. 3.125. Now, any questions, please? Okay. Now, what happens is the moment you have calculated this, how do we take a call? You compare the Z value that you have calculated, then we have already discussed the Z critical value, which is 1.64 in this case. You compare those. Z value is more than Z critical value. Yes, it is more. Then we fail to, we say we fail to reject the null hypothesis.
Correct. When Z value is greater than Z critical, we are rejecting the null hypothesis.
We are rejecting or we are failed? Yeah.
No, rejecting. When Z is greater than Z critical, we are rejecting.
No, we fail to reject, right? No, 1 second.
No. When Z is greater than Z critical value, we are rejecting the null hypothesis. This is left tail or right tail?
The right tail only.
Right tail, right? So then it's Z is greater than Z critical, we are rejecting the null hypothesis.
Correct.
So I think the way the Z table is defined, whenever you get a Z value, it gives you the left-hand side value only.
Correct.
That's how it is told. And since it's a right hand, which we need to really look at.
Yeah.
Best way is to draw the bell diagram so that it will make it very.
This is left hand, I think. Less than, yeah, less than. So it is.
Yeah. So I have to actually introduce this concept then. Give me 1 second.
Let me see where I had solved that problem. We'll see what is the value get done.
Okay. Now here is a bell curve. Okay.